Hello kids, let us see dividing expressions. It is unlike dividing integers itself. So how do we divide two integers? Like if I have 20 to divide with 5, how do we divide basically? So 20 over 5, or we can see that, so which is 4 is the answer. So dividing with, which is same as dividing expressions also. So let's see that individual terms we have to divide with. First I'll take one example and I'll show you. If I want to divide x square with 2, so how do I do that? So I can directly write as x square over 2. So to divide we have to see the common factor. So since in this case you can see that 5 is a factor of 20. You can see that 5 is a factor of 20. But what about in this case? In this case 2 is not a factor. 2 is not a factor. So we can't divide. So we can't divide further. So that's where we have to leave. Got it? So x square over 2, where 2 is a factor of 2, where 2 is not a factor of x square. If it is a factor, we can just simplify further. So let's see one example with a factor. So this is the first example and then second example. So 4m square n has to divide with 2mn. In this case, let me write as a fraction form. So 4m square n over 2mn. So here what I'm trying to do is to make simplification very easy. I'll expand this using expanded form operation. So let me expand this. 4 I can write 4 itself, and m square I can make it as m times m, and then n over 2 times m times n. And just to make easiest, I'm trying to expand this, and let's strike off the common factors. Like 2 is a factor of 4, right? So 2 times 2, and m cancels out, factor, and then is a factor of n. So nothing is remaining in the denominator. If you can see the numerator, so 2 is remaining and then m is remaining. So 2 times m. So as we know that 2 times m is 2m is the answer. So what is the result if I divide 4m square n with 2mn? So I got 2m as the result. This is how we divide the expressions. So let's see one more example. So in this example I'll show you how to divide dividing one term expression. So dividing one term expression, one term with 3 terms. So let's see. So one example I'll put it here to understand this concept. Example, minus 42 x square y plus 12 y square minus 4xy. This has been dividing with 2xy. Let us see what happens if I divide an expression which are having 3 terms with 1 term. So let's see that. Minus 42 x square y plus 12y square minus 4xy. So that is to be divided with 2xy. So as we have a basic rule that the denominator can be split over anything. If x plus y over so some k, we can just make it as x over k plus y over k. So where k is a common denominator. So apply the logic here and expand this numerator. So let's see, minus 42 x square y over 2xy, and then plus 12y square over 2xy, and then minus 4xy over 2xy. So let's see the common factors and then strike them off. So if you can see that the first one, 2 will be cancels out in this, 2 21s, and then negative 21, and here you can see that 2 times 6, and here you can see that 2 times 2. So I have cancels out all the coefficients, and let's talk about the variables. there is only one x is there, so out of 2x one term will be cancels out, and then y is a factor of y, it is completely strikes off, and x we can't do anything but y, so out of 2 y's you can cancel out 1, and then x cancels out and y cancels out. So let's write the remaining part what we have left here. So let's talk about the coefficients. So negative 21 is the coefficient left over, and other than that there is one x is remaining here, so negative 21 x, and then plus here 6 is remaining the coefficient, and if you can see, have a look at that, y and x are remaining, so y is in the numerator and x is in the denominator. So let's write that 6y over x, and then minus 2, there is no variable is left off. So this is what the final answer. If any like terms are there, then we can add it up. So look at that, these two are not like terms, this is the variable in x and this is in y over x, so we can't further add it. This is how we divide the terms of the expression with the other expression. That's all for this. Thank you.